Okay.
Okay, so polynomial word problems. Okay, the first graph is describing temperature. The temperature over a 4-hour period. So let's talk about this graph and what's going on. So there's time and there's temperature. Axes, where do you want to put the time? X or Y? The time goes along X and the temperature is going along the Y. That would make sense on a graph. What do you know about time? It can't be, you can't have negative time. So really that part of the graph doesn't really make sense. So the temperature is doing what? Temperature's increasing, and then it decreases, and then the temperature goes back up, and then the temperature decreases. Eventually, this just doesn't make sense, right? Like minus 1,000 degrees just doesn't make sense. Eventually doesn't make sense. Okay, so I don't have a specific time where it's like, boom, this is done. It just, eventually we're just saying no, it just doesn't relate. Okay, so in a domain sense, well, we for sure know the domain would, we know that at least, right? 0 to something. But we don't know. Okay, so we're going to make an equation. You ready? I'm going to go y equals, I'm going to leave a spot. We can call it an a value. Okay, I need a factor. What's this? X-intercept of 1. So what's the factor? X minus 1. Oh, it's bouncing there. Squared. Then there's an x-intercept of 2. So what's the factor? X minus 2. And then there's an x-intercept at 3. Okay, how do I figure out what A is? Is there anything else on this graph anywhere else? Yeah, the y-intercept, which I ever so nicely scratched off. 0, negative 12. So what I'm going to do is plug that in. So y is going to get replaced with a negative 12, and x is going to get replaced with a 0. So it's me plugging in the coordinate 0, negative 12, and then we'll figure that out. Okay, so negative 1 squared was 1, All of that times is to be what? 6. So A equals negative 2. Is it making sense for you to know that A is negative because of the shape? Right? It's not a W, it's flipped. So final equation, y equals negative 2, x minus 1 squared, x minus 2, x minus 3. Okay, on your test, please pay attention, and in your homework, here I'm using y's and x's. I might have on the test use an H and a T, or, okay, just be careful of your letters. Find the temp after 4 hours. So what am I going to do? 4 hours is a time. So I'm going to now plug in a 4 to replace the x's into this equation, because now the time is 4.
already in hours, sorry.
Everything is in hours, isn't it? Or what? It's just at the top, it just says in a 4-hour period, yeah. So -2 bracket 4 minus 1 squared, 4 minus 2, 4 minus 3. So that's me plugging 4 into all the x's. Okay, and then I need a number with all that, and you can just do all that. I don't even have what we are. I don't know what we are. -36 degrees. I don't know. There's no units on this, so okay. Does that work? Is that what you got? Does it make sense on the graph? We'd be like going down, right? -36. The last question says, estimate the max temperature. Okay? So, FYI, if there is actual tick marks here, what you would do is just look over to say, boom, how high is that bump? Right? That's if you knew. But here, I didn't give you that. So, I'm trying to find this. And here's what you're going to do. I'm just going to estimate, so I'm going to use an x value of 2.5. Does that make sense? Because it's just an estimate. It's not going to be that exact thing, but you don't know how to do that. If you took calculus, you would know how to do that. John, start deriving that and max it out. Okay, so y equals -2. Okay, so I did the exact same thing as I did with 4, but now I'm just putting a 2.5 in there. Okay? And then somebody can tell me what that comes out to be. Because I got to get ready for the next example. .13. Is there any more decimals?
Well, it's 1.125, but I just...
Okay, 1.125. Okay, you ready for the next question? Okay, here's what you do. You start with a piece of paper. I'm starting with a piece of paper, and I'm going to cut some amount off of each corner of my paper. Okay? Everyone's good with that? I'm going to cut a square off of each corner. Okay? So this is what it looks like. Okay? There's my paper. Now, what I'm going to do is I'm going to take these sides now, and I'm going to fold them up. Maybe you've done this before as a little kid, putting this in the water. And now I have a box, yeah. Okay? So,
that lunch tray. I just got hungry.
So I cut the corners out. So good to have a visual. And then I folded it up. And I made a box. Okay. Here's the deal. We started the piece of paper. I guess we had a square paper. We had a 6x6 paper. And I cut an X amount out of the corner. I cut off X amount out of the corner. Cut off X amount in the corners. So, here's the big question. What are the new dimensions of this box? Okay, so how do I represent this new length from here to here in math?
6 minus 2x.
You had 6 and you subtracted 2 x's off. You see it? So this is also 6 minus 2x. And once we folded it up, what was the height of this wall? X. Okay, my drawing, I should have drawn a square, Chris. I'm sorry.
What a boy, Chris. Using that line for something good.
You're right, my drawing is not square-y. It's more rectangle-y. Okay. How do you do volume of a box? Length times width times height. So, length times width times height. Boom. There's my equation. Model this equation with a graph. So we're going to graph. So what's the x-intercept in that bracket?
Yeah, what I understand.
Yeah, you're right. Just like,
Okay, I'm going to go to this side. I'm going to go to the side. How do I create that equation equal to 0?
6 over negative 2.
3. Does it make sense? If you cut off 3 and 3, you would have what left? If you cut off a 3 and a 3 on your paper.
What?
If you cut off 3 and 3, what would you have left? You have nothing left. Okay. And this is the same. X-intercept. So what's going to happen at 3?
A bounce. Bounce.
There's going to be a bounce there because that was a double, right? Some people choose to write this, right? Because it doubled. And what else is the x-intercept here?
0.
0. So 0 and 3 are your x-intercepts. What's the, it's a letter. What letter am I going to do if it's a volume? Cubic, volumes, cubic. We have 3 x's, it's an n with a bounce.
Going the other way for the 3 because it shows a positive, so I'm going to become negative on the graph.
If I multiplied this out and I started with how many x cubes, it would end up being positive x cubed. Okay, here's why. Because this one has a negative 2x times a negative 2x. So now I'm positive times another x, still positive. So that's where I'm getting the positive from. Okay,
this reminds me of Chris.
model with a graph done. Part C, discuss the domain. So what do we have here? We have x, which is the cutoff. And then what's my other axis all about? What are our two variables? The volume. The x cutoff, and then we're getting the volume. So is there parts of the graph that are not good?
The past the 3 and the 42.
Past the 3 is not good. Before the 0. Okay, so paper says I can't be past 3, example 4. Because remember, your paper's 6. Can you cut 4 and 4 off your paper? No, you don't have enough paper. And can you cut off negative paper and have negative volume? No. Okay, so the domain goes from 0 to 3, but we have to be careful about our brackets.
It can't be exactly 0 and it can't be exactly 3.
You can't cut off exactly 0 because then you have no volume. You don't have a box. And you can't be exactly 3 because then your side's all gone. So the round. Part D, estimate the max volume. So the max volume is in there somewhere. And we're estimating, so is it okay if I just pick to plug in a 1.5? You see where I would just estimate? There's a 0, there's a 3. I'm going to plug in an x of 1.5. It's not going to be the max necessarily, but it's an estimate. So volume equals 6 minus 2, plug in x, squared times, so I'm plugging it into my equation from up there. Okay, and that would just get me an estimate of my max volume. Is anybody getting 13.5?